Good morning, everyone.
Good morning.
So from next week, I guess we can have the lectures online, since no one is attending the class here. So,
Sir, today I have an office. That's why I'm attending from online.
which is easy for you to follow, online, yeah, offline, which is easy.
Sir, offline classes. Just because today is the office, I was not able to come on offline.
क्या हुआ? Last session आप नहीं थे क्या? I think last session there were only 2 people. Most of them were online. Just 1 or 2 people were there. I was on. We had the theory on linear regression. So today we are going to start the hands-on linear regression. Okay, I'll share the data set, what we are going to work on, and then we can start. Okay, how do I share this data set? Okay. कोई ऐसा, do you have any common repository or something? ठीक है, can you share one of your email IDs? Then you can forward it to the others. लिख दो ना यहाँ पे. So I'm sharing the data set. I have shared it with Yash. No? So he will forward it to you. Kindly download the data set and then we can start. Are you comfortable working on Spider?
We haven't done that.
Like, yeah.
तो मतलब पिछली बार क्या था तो Python के basic.
Okay, get used to Spider. Is the Spider app installed? Do you have the Spider app? Okay. Mila, have you got the data set?
No,
Okay. Is my screen visible to everyone, people online?
Yes, sir. Yes, sir.
Tomorrow, I don't think you have a lecture, right? It's a holiday, 2nd October. Okay. Meanwhile, I'll just take you through the data set. Okay, this is the data set, and this is the description of the data set. So the variable names are given. So we have to predict what is the cement strength. Okay, given a set of features. Anyone from civil here? Civil industry, any background? So how much, what should be the cement strength? Okay, that is what we have to predict. And the features given are, okay, first identify which is the Y variable. Okay, so we have the CCS, concrete compressive strength. CCS is the output variable. Okay, concrete compressive strength. So which is the Y variable here? CCS, the last one. This is one. Okay, mostly Y variable is either the first column or the last column, usually. But that need not always be the truth. Now, what are the features? Cement composition. So the first variable quantitative kilogram in M3 mixture, okay, input. Then blast furnace slag, fly ash, water, superplasticizers, coarse aggregate, fine aggregate, age. So we have all these features here: cement composition, slag, fly ash, water, etc., etc. Okay. So what are the requirements for linear regression? Feature requirements, what are they? Y variable should be number. So we have numbers. What should be the input?
Numeric.
Input should be numeric, or it can be categorical. Okay, it cannot be a string, it cannot be a date. Okay, unless you have a date component which is relevant. So here, both those things are missing. There is no category also. So what we have is numbers. Okay, good. What are the EDA activities that you will do?
Correlation.
Correlation. Then
Outline.
outline is good. And null values, check for nulls. Okay, then
Base fit line. Base fit line.
no, that is not EDA, that is the evaluation. Normal distribution check, that is the assumption, isn't it? So we'll check whether they are normally distributed. Okay, if it is not, we'll try to convert. That's a different part of the implementation. Should we look at the third column?
We can talk the learning one.
The third column is fly ash. And if you look at the initial 10-15 records, what is it?
Zero.
Zero, not null. Big difference between null and zero. Is zero a good value or a bad value?
Bad.
Always.
It can be good, it can be bad.
It can be good, it can be bad. Okay. Now, this is where your domain knowledge will really help. Now, how do I know fly ash is good or bad? Sorry, fly ash of zero is good or bad. Okay. Just because a zero is there doesn't mean that it is necessarily a good value or a bad value. Okay. So if you know the background of civil engineering, I mean, you cannot be an expert in all the domains, but in case if you have studied or done some work, you will see that fly ash is optional when you are mixing cement. So that's why fly ash is zero. It is a valid value. Okay, same goes for others, water, superplasticizer, even super, if you look at the values, there are some zeros. Okay. Then what else? What are the other things that you will do?
Normalize.
Yes, you can normalize. Not compulsory, but if you want, you can do it. Now, there is another term, I'm sure you must have done this, that is called singularities. Did you implement it in your hands-on? Singularities means a given column, when a given value is repeating 85% or more, then that is called as a singular or singularity. Singularity columns don't have predictive power. Okay, because of high bias. Okay, for example, if you look at fly ash, the total number of records I have is around 1,000. If I see, it's 1,030 records. Okay, that's good. There are 1,030 records, out of which my initial records were zeros. Okay, so 85% of 1,030. So that is roughly around 900 odd. So if 900 records have fly ash equals 0, it means that it is exhibiting singularity. So as a feature selection method, I can remove that column from my data set. Okay. Same goes for categorical features also. When you have a categorical data, let's say there are 3 categories. Let's take 2, for example, gender, male, female. Okay. If the total count is 1,000, out of which 950 records have a gender female or male. Okay, because that is the majority, 90+%, you can remove that feature from the data set. Okay, so we will do that check also. Are there any singularities with respect to these numeric features?
Age might.
Age?
Age column.
Age also. Okay, then what else? EDA is over. Then outlier check using box plot, distribution using histogram, and then correlation using heat maps, null check, zero check, singularities. Okay, so these are the initial steps. Then the basic checks, how many rows, how many records, count and all that. Okay, column names. Now, another thing that you can do is look at the names of the column. Cement comp, super plasticizer, coarse aggregator, fine aggregator. You can shorten those names. Okay, just for quick processing. Okay, it's not compulsory. Once these things are done, what is the next step? Splitting the data into train and test. Okay, then the model building process. Then after that, summary of the model. And then the assumptions check. And after that, the prediction. And then getting the model to perform, evaluating the model. Checking for heteroscedasticity, that is part of the model evaluation. So if it is heteroscedastic, how can we improve the model and make it homoscedastic? So if you remember last class, we discussed heteroscedasticity, we need to check the degree. Okay, because data cannot be converted to a homoscedasticity always. Okay, so how much heteroscedasticity are you okay with? That is what we are going to plot in this. Okay, so either convert the data which is the features, or convert the y variable, any one of these two. When we convert the y, that is called, what is the process of converting the y variable? Box-Cox transformation. Remember we spoke about Box-Cox. When we are converting the features only, keeping the y as it is. That is called transformation using the standard procedures that we know. Okay, log transformation, inverse transformation, square root transformation, etc. When we are transforming the y variable, keeping the features constant, that is called Box-Cox transformation. Okay, raising the y variable to a lambda. Okay, so lambda is a power. When converted into that power, the distribution tends to become normal. That is called Box-Cox. Okay, we'll do these steps. Okay. So first confirm if we have got the file. We'll get. Okay. And what is the evaluation technique? How do you know that this model is good? In linear regression? Look at your notes.
Training, the accuracy of training data is similar or equal to testing data set.
But in linear regression, do we have accuracy? We have the residuals or the errors. Okay, so we use the RMSE or the MSE. Okay, or APE or MAD. There are many techniques. You can use any one out of these. Okay, usually we use the RMSE, root mean squared errors. I can also use the AIC to evaluate. Okay, these two. Okay, so let's get started. So we have linear. Are you okay with me typing? You will type parallelly, or should I send you the code? Kaisa chahiye? You'll type parallelly. Okay. So we'll be writing a lot of functions. Okay, not control enter, one function which is going to be generic, which can be used for almost all data sets. Okay. So data set is going to be concrete. So first thing is import the libraries. And the model that we are going to build is the OLS model, ordinary least square model. There are different models. One is a linear regression model, OLS model. The advantage of OLS is that it gives you a summary. Okay, what is the use of the summary in linear regression? Summary of the model, not summary of the data set.
It gives correlation, p-value.
It gives you the feature importance. Okay, how important are these features if they are to be retained or it can be eliminated. Okay, so let's start. So import pandas as PD. Import numpy as NP. Stats models contains the library OLS. Then import matplotlib.pyplot as PLT. This is to plot the histogram. Import Seaborn as SNS. Have you worked on these two libraries, Seaborn and Matplot? Then Backlog logo sleep on the again. That is the library for. From sklearn.model selection, train test split. This is going to split the data into training part and testing part. Then we'll import another library called stats.api. So this is for heteroscedasticity check. Then we have one more library called K-fold. Now K-fold is a library for performing the cross validation. Okay. In the last class, we saw the concept of cross validation. What is K-fold cross validation?
Okay, all value can be verified with the each order. First one can be K1 is selected for validation, and then K1, K2, K3, K4 selected, and validate the data is correct or not. Up to 5.
No, not up to 5. Correct. So K-fold cross validation is a technique where we take the training data, do the model on that, and do the evaluation on the same data. Okay. Screen zoom, 1 minute. I can do one thing. Better? Then from sklearn import pre-processing. Pre-processing will be used in case if my data is to be converted into some other format like Z-score or other distribution. Then from sklearn.metrics import mean squared error, which is the MSE. And the square root of this will give you the RMSE. Finished? Next step is read data. So I'm going to call the data as concrete equals PD. Does it make any difference if I use the backslash or the front slash?
Backslash is next line.
So if I give a directory like this, d:\new file1 dot text, is this valid or not valid?
Not valid.
Q? You are right, it is not valid. But why is it not valid? This is a proper file name. If you look at the path here, in the prompt, you will see only like this, d:\new file1.txt. But why is it not valid? What will happen if I give this path? And how do I fix it?
It is backtracking the path.
Money?
So it is going in D. Like it is starting from using.
Assume we have a path, a directory, d:\new, okay, and I have a file in this directory. I'm setting the path like this, d:\new/file1.txt. I want to read this file. Python will not read this, or you can put CSV. And I give read.csv, give an error. Question is why? You can try it out. It will say file not found or invalid something. See, the /n is an escape character. Now in computer science, there are something called escape characters, which have very specific meaning. Okay, for example, if I give /n, it means new line character. If I give /t, it means it's a tab character. So it is going to replace /n with an enter. Okay, so here, what is the file name? It is d:1 line EW and then file1.csv. So there is no such directory like this. Okay, so this will give an invalid file name. So that is why I put the other slash. Okay, which is the unique style notation. The other way you can fix this is give one more slash here. So double slash means that you are telling the compiler, do not treat that as a escape character. It is a valid value, the slash. Now it will read it as a proper file. Okay, I prefer this method, the first one, because too many slashes, if we have a long path, you will have too many slashes that can be a bit difficult to read. Clear? So now let us read this file. So read underscore CSV and file name. Now we can just check print. Then you can do some basic checks. Count the number of rows and columns. So concrete.shape. So shape will give you in a tuple format how many rows, how many columns. So 1030 number of rows and 9 is the number of columns. Conc.columns will return the names of the columns. Now here, if we want, we can change some of the column names because they are quite long. So cement comp, so we can change these column names. So to rename the columns, we have a function called conc.rename. And what are we going to rename? We are going to rename the columns. And then in a dictionary format, you give the old name and then the new name. Okay, this is the structure. So in the new old name, I'm going to give cement comp. So replace cement comp with a smaller name. So maybe I can give cement composition. Super plasticizer, I can rename this to, let's say, super. For course aggregator, I can rename this to CAGGR. Okay, these are optional things that you can do as part of your ADA. And then just check whether they have been changed. So conc.columns. And here you can see that you are getting smaller names which are easy to read compared to the lengthy names. How did you do your first implementation? House price data, something similar? Cars. Car price prediction. Okay. Did you follow the same pattern? These are basics. You have to. Rename is optional. Okay. What is the next step? Check for nulls and zeros. So conc dot is null dot so the output of is null, it is going to give you the column names and the count. So 0 means there is no null value for the corresponding column. So here all are zeros. That means there are no missing values or nulls. Now for 0, I can use conc. So here you can see slag, there are 471 zeros. Fly ash, 566 records having 0 values. Super plasticizer, 379 zeros. So should we fix these values?
How do we run a single line in Spider?
Single line.
Yeah, I want to run only line 38.
Control enter.
Just that line.
Or you can check what is the shortcut key.
Because if I do,
you go to the option. Yeah, I think I know what go to the tools option in the menu. Then go to the preferences. And on the left hand side, you have on the list of tabs, you have an option called keyboard shortcuts. Okay. So select that, then come to the right hand side. And you need to look for the string current line. look for this line called entry called run selection. Okay, and see what is the shortcut key map there. F9. Finished till this point? Online people, any questions?
No, sir.
So next is we will summarize the data set. So summary will give you the basic statistics of the data, which is the numeric data. So I can use conc.describe. So the describe function will give you for every numeric data, what are the basic statistics. For example, the cement composition, what is the total record count? So you can ignore the first line. What is the mean? What is the standard deviation? What is the minimum value? What is the first quartile? What is the median, which is 50%? What is the third quartile? And what is the maximum value? Okay. So from this, okay, look at the describe function and look at the value for age. Do you think you have outliers in age? So is that an outlier, a statistical outlier or a domain outlier? So these are things that you cannot answer it just by looking at these numbers. Okay, so this also requires a little bit of understanding on the data, okay, the domain. Because if you look at the value 365, what number does it, what does it, which unit does it represent? Age 365. The unit. Can it be years? Or is it days? Gut feeling. It is obviously days. Okay, cement can't be 365 years old. So it is going to be days. Okay. Now, whenever you are writing any these generic functions, okay, try always to split the features. Okay, we have features, that is the columns as features and y variable. Okay, so try to split them into two. One will have the features, that is the x variables, and the other will be the y variable, because it is going to be used a lot in the functions. So we already know what is the y variable, which is CCS. So this you can hard code. Is it CCS or CSS? CCS. Then what are the features? So features equals concrete dot columns. So first convert this into a list. And then remove the remove doesn't work like this. Okay. So for y variable CCS, then all the columns converting into a list. If I don't convert it into a list, it becomes a NumPy array. Okay. So from a NumPy array, I cannot use this remove function because that's a Python list function. And then converting into a list. Then from this list, I am dropping this entry, the y variable. And now if I print the features, it will be all the features.
Pop does the same thing. Right?
Pop does the same thing. There are three ways to remove it. Kya hai? Del. But for del, you need to know the index position. Pop, you need to know the index position. For this, you need to know the name of the value. So here, name is more convenient than knowing the index position. Index position agar karna hai, then you need to use the index function. List.index. then the y variable name, it will return a value, then use that to do a drop. So 2 steps. Here it is 1 step. Up to you, whichever is convenient, use that. Okay. Now we are going to check the normality of the data. Now, how do you check the normality of the data? Number one is you can plot the histogram. Okay. Now, sometimes histogram, even though it looks normal, but in reality, it may be not a normal distribution. So you can do 2 things. Number one is the histogram, of course, that we're going to do next. There is also a hypothesis testing that you can perform on the data. आपने किया था statistics पे? Did you do any of these things? What are the tests to be done to check for normality? Do you recall anything? नहीं. Normality के लिए there is a distribution time पे you probably would have done it. It is called Shapiro test. Yeah, I'm sure. And then there is another test called Agostino test. Shapiro test has a limitation that it works only for a certain number of data, which is around 5,000 or 50,000. I think it is 5,000. Agostino there is no such. So all these tests work on certain assumptions. Okay, so we'll implement both these, Agostino test and Shapiro test, and we'll see what they return for these distributions. Okay, we'll write one function here. So function name is check normality the input. Now for checking the normal condition, my data has to contain only the numeric columns. Now luckily in this case all our features are numeric data, so we'll pass the features as it is. Okay, but ideally it should be only numeric columns, and the output will be it is going to return so we'll write both these tests, Shapiro and Agostino test. So it will contain 2 parameters. What is my input data? What are the list of columns? Okay. So I'll create 2 lists which will contain the status, whether it is normal or not normal. Okay, and same thing. For Agostino, I'll create a list which will contain the values normal, not normal. And then I'll compile everything into a data frame, which will give me 3 columns, name of the column, Shapiro test, what is the status, Agostino, what is the status, and then compare this with the histogram. Okay. So for every C in the list of columns. SHAPIR. That's the Shapiro. So for Shapiro test, I'll be using this function called stats. Let me check. Stats I have not imported, that's why. Import. Very good. Okay, just include this line from import scipy.stats as stats. So null hypothesis data is normal. Alternate hypothesis not normal. Okay. Just run this function and check. So for Agostino test, the name of the function is normal test that takes the parameter. What is the column name or the array? And this will return the same parameters, p statistic and p value. We can store all the values in a data frame. So normal distribution equals pd.data frame. Feature will be the column names. Sorry, not Augustine. We'll start with Shapiro test. Compile this function. Function clear? So create two lists. One will store the result of Shapiro test. One will store the result of Agostino test. You're looping through the columns. Okay. The Shapiro test is called stats.shapiro. And the Agostino test is called normal test. You can do it in the same for loop also if you wish to, since the values are going to be similar. And then checking for the p-value. If it is significant, I'm going to append the value normal. Otherwise, I'll be appending the value not normal into the lists. And the resulting data frame will have feature name, the string normal or not normal for each of the columns based on the test. Okay, so let's run this function and see. Test for normality. So the name of the function is check normality. The data is concrete data. And the list of columns is features. Okay, so it will return a data frame like this. The feature, Shapiro returns this, Agostino returns this. Finished? Now in this function, I have not taken the y variable to check the normality. Is that compulsory to pass the y variable also here? Not mandatory, but if you want, you can pass that also to check whether it is normal or not. Okay. Because even in the y variable, you can have outliers. Online, any questions? Okay. Next, we will write a function to draw the charts. That is the histogram, box plot, and heat map. Okay, we'll write one function to plot all the three. The chart will depend upon what kind of parameters am I passing. And based on that, it is going to display those charts. Okay, so we can write a function called plot charts.
Sir, for the p-value in Agostino and the Shapiro test, it is going to be taken from the model, right? Stats test model or normal test or Shapiro test? The test value and the p-value?
That is the return from the function, which is Shapiro and normal test. This one. The output of this function will return two values. What is the t statistic and what is the p value?
Okay. Yes, got it.
What was your question?
Yeah, I was just confirming that p-value is going to come from this function, like stats.Shapiro and this.
Yeah, this function returns two values. That's why I have two placeholders.
Okay.
So I can either check for p-value less than 0.05 or I can test whether t statistic is greater than 1.645.
Yep, got it.
So the plot. So in the plot chart, I will write three parameters. First is what is the data. Now, what kind of features are required for histogram? X and Y? नहीं, feature data type क्या होना चाहिए? Numeric data, right? For box plot, numeric. For heat map, again numeric. Okay. So when you are passing these column names, we already have extracted the features. Okay. So this is going to be the same numeric columns. NC is numeric columns. And then what is the chart type? So I'll have three input feature parameters for this function. So NC is the numeric columns. C type is the chart type. Now I can define my own chart types. For example, if I'm drawing a box plot, I can call this as B. So B for box plot. For histogram, I can write H. And for heat map, you can give maybe HM. Okay, choice is yours. Now, if I plot, if I give a parameter, say XYZ, what should happen? If I give data as concrete data as the first parameter, features as the numeric columns, which is my second parameter, and chart type, I give XYZ. So ideally, what should happen? It should give an error. If not, it will. It should give an error. Okay, so you have to code that so that you don't pass an invalid value. It should be one of these three. Okay, so first you can. So if C type in so what are the valid values? So we have B, then we have H, and then we have HM. Okay, so first write a simple if condition to check whether the chart type is a valid one or not. And you can just check it out. So my data is going to be concrete data. The numeric columns are going to be features. And the chart type, suppose I give XYZ. So is it throwing the error? So just check. And here it says invalid chart type XYZ. Okay, so that is taken care. Now we'll write the main function. Okay, so first let us write. Let us plot the heat map.
So for the function check normality, I'm getting an error. All arrays must be of same length.
Shape to it. Lay down like this. It shows me features. No, features here. Problems. Put this inside the volume. Inside the volume. This is too small. I don't see it. Have a main feature is not defined. Feature are features stance is not defined, so define the stance. Side by SCL dot stance S stance is okay. Done. So first we will plot the histogram and box plot. So the condition is if C type in H B. Okay, so if the chart type is a H or a B, then I'll be plotting either the histogram or the box plot. Else, it is going to be the heat map. Now the chart that I'm going to plot, it is going to be in a single canvas. I'm going to plot a n by 2 matrix where n is the number of rows I want and 2 charts in each row. So if I have 12 columns, it is going to be a 6 by 2. If it is going to be 9 charts, then I'm going to take the integer value of 9 by 2 and then plot it accordingly. So 4 rows or 5 rows, 2 columns. Okay, so that's why I have this if condition here so that I can define how many rows and columns I want. So the number of rows that I want is going to be numeric columns divided by 2. So the number of columns are 9. So 9 by 2 will be 4.5. Okay. So 4.5, if I take a ceiling value of that, you understand the ceiling and float? Ceiling means the next highest integer. Okay. So NP dot ceil. So 9 by 2 is 4.5. So ceiling will return 5. So 5 rows. And then convert the rows into an integer value. So int of I cannot have the number of rows as 5.0. It has to be an integer. Okay. Now, if you look at this, 9 by 2, 4.5. Okay. Now, if I convert this into a ceiling, this will return a value 5.0. Okay. Now, I cannot have a fraction rows. So this I have to convert it into an integer value, which is fine. Okay. So this is what I'm doing in this function. So int of ceiling of this. How many columns I want? 2. I'm going to fix it. Okay. 2 columns. And then I'm also going to define when you start plotting each of these charts for every column. So every column will occupy a position. Okay. So let's say that there are 8 columns. X1 position 1, X2 position 2, X3 position 3, X4 position 4. So I need to define for each position which chart. So starting from the first position. Clear? Now loop through every column. So for every column in numeric column. So these are some other things that you can set. That is the scale, the output, the outer canvas. So font scale equals 1 will mean that it is going to print in small. And then color codes. So it will take some default colors. So first plot the outer figure, and inside that you will be plotting the subplots. You know what is a subplot? मैटप्लॉटली पे किया था subplot by any chance? See, first you define your outer plot. Okay, this is my outer plot, and in this I'm saying how many rows I want, how many columns I want, which I have already defined in the rows, uppercase columns. Okay, now how many columns I want? 2 columns. Okay, now this outer canvas will contain the individual histogram or the box plots. So those are known as subplots. So if I have 5 columns, if I have 10 columns, so I'll have 5 rows and 2 columns. So here I'll have the first chart. Here I'll have the second chart. Okay. Third one and fourth one. So each of those small boxes are known as the plot subplots. So first define the outer plot, then each inner plot is a subplot, which can either be a histogram or a box plot. So that is the condition I'm writing here. Define my figure, which is the outer plot, and for every column, which is going to be a histogram or a box plot, depending upon the chart type. So fig dot add underscore subplot rows, columns, position. So this line means that in my subplot, the total number of rows are defined here. The total number of columns are 2, which is defined. And at which position I want to plot my subplot. So position is 1. And after plotting this, I am going to increment the position by 1. So when the next subplot comes, it will be in the second position. And then it goes on and on. So at this position, which plot I want? If the chart type is H, then I want a histogram. If it is a H, it means a histogram. In the else part, it is going to be a box plot. You can give a label for that. Is the code clear to everyone? Dist plot is the distribution plot. This is the heat map. Finished? Let's execute this code. No errors. Now let's see for the histogram first. Okay, so first parameter is concrete. Second parameter is the features. Then if I pass H and int of np.c. Okay. Should be length of NC, isn't it? NC is the numeric columns, but I want the length of that. This. Okay. Now you can see here that it is going to plot the histogram like this. So there are going to be two columns and number of rows decided by the total number of features. So 1, 2, 3, 4 rows and 2 columns. And this is position number 1. This is position 2. This is position 3, position 4, position 5, 6, 7, 8. Okay, so each of these are the subplots. Now, if I want to plot the box plot, I will write plot charts. The data frame is called concrete. The list of columns will be features. And the third parameter is going to be B. Okay, and now I'll have the box plot for each of these columns. Error. No, it is not NC. NC is the numeric columns. It should be length of it. Online, people, have you finished till this point? So this is the complete function. इतना ही है फंक्शंस हो गए अभी सिर्फ उसको कॉल करना है फंक्शन कॉल so with the right parameters h is for the histogram b is for the box plot Done? Are you able to see the charts? The last chart we'll do is the correlation chart. So correlation, if we have seen, if x1, x2, x3 are three features, so it is going to draw the correlation chart of all the features. So x1 and x1 is always going to be 1. x2 and x2 is always 1. x3 and x3 is always 1. Right? Then x1 and x2, we'll have some numbers here. Let's say 0.01. So x1 and x2 is the same as x2 and x1. So even this will have 0.01. x1 and x3, if it is 0.5, x3 and x1 will also have 0.5. So you will see a lot of repetitions. Okay. So in Python NumPy, you have a way where I can take only one triangle to show the values. The other triangle will be filled with zeros so that the analysis becomes proper. Okay, so this is called as the upper triangle or the lower triangle to draw the correlation map. Okay, so we have a function in NumPy which is called TRIL and TRIU. Lower triangle and upper triangle. So we'll see these how to implement and then we'll take a break. Ankita, can you share your screen, please?
Yes. Am I visible?
Yeah. So so the number of let's see. There is an extra bracket after LEN. There is an extra bracket. Remove one of them. So 1, 2, 1, 2, 3, 1, 2, 3. Yeah, now it is okay. Okay, now change that last parameter to H and you will see the histogram.
This I've changed with H.
So H is the histogram, B is the box plot.
B is the box plot.
Yes.
Thank you.
Okay. So now we'll quickly do the last part, which is the heat map. Now break pe I'll have a look. Break pe dekho. So to draw the heat map, I want the correlation matrix of the data. So data of the numeric columns and the correlation function is CORR. And then I have to remove the upper triangle or the lower triangle, depending on what you want. So I want only data on the lower triangle, upper triangle, and make it 0. So there is a function called np.tril. So this will retain the values in the lower triangle. And the upper triangle will be filled with zeros. Then use the heat map function. So heat map function will take the first parameter as what is the correlation matrix. Then what are the labels for the x-axis and the y-axis? And that is called x tick labels, which are nothing but the numeric columns. Then what are the y-axis labels? That is called y tick labels. That is also the numeric columns. Now in the chart, I want the numbers to be shown. So I'll use the annotation. To be true. What is the limit of correlation? कोरिलेशन का लिमिट ये क्या है? लिमिट क्या है? -1 to +1. Okay, so I'll give the limits as -1 to +1. Okay. So the heat map will also plot along with the values. It will also plot a color graph. Okay, so depending upon the color, you can find out the correlation. Then print so this is now for the heat map, I can use plot charts. The name of the data set is concrete features. And the flag I have used is HM for heat map. And now you can see the values and the upper triangle will be filled with zeros. Are you able to see the chart? Correlation matrix. So how many features have high correlation in this data set? How do you read this chart? How do you read the color code? The right hand side, you see that vertical line, that is the color chart, color code rather. Okay, center value is 0. Bottom it is -1, top it is +1. So wherever you have a high negative correlation, okay, color will be black. And if you have a very high positive correlation, the color will be white. So when you go from 0 to +1, the color goes from brown to white. And if you go from 0 to -1, it goes from brown to black. Okay, so darker the color, more negative correlation you have. And when you have lighter colors, it means positive correlation. Okay, so here you have both the options, the colors as well as the numbers. So annotation means these numbers. So now you can see which feature is related to which feature. Are there any multicollinearity? Okay, if there are, then you can remove one of them so that you don't have the problem with multicollinearity and overfitting. Okay, we'll continue with this model after the break. So when you write these functions, it becomes one time. You don't have to keep writing the same thing for other models. Just copy paste it or create a different library and just import it. There are lots of shortcuts available. You have different libraries. Don't use shortcuts for now. Get into the habit of coding. Okay, online people, any questions? Are you all able to plot the 3 charts? Okay, so we'll take a break. It's 11:15. We'll meet by 11:30 and continue. So next we have one function to split the data and then build the model. And then Chalo, let's start. Now, because we are going to build multiple models and each model will have the different split criteria splitting the data. So we'll write a generic function for that. Okay. So define split data. So this will take 3 parameters. What is your data? What is the y variable? And what is going to be the ratio? So I'm going to default the percentage as 30%. You can change that into any number that you want later on. So the function is train test split. You know how the train test split works? Have you used that? Yes.
Sir, before we were explain how to read the heat map.
How to read the heat map. Okay. Just give me 1 minute. Let me finish this part. So the train test split will take 2 parameters. What is the train data? And what is the feature? And what is the y variable? Okay. And this is going to split the data into 4 parts. So this will become train X and test X. And the Y will split into 70-30 as train Y and test Y. Okay, that is a function of train test split. So train X, test X, train Y, test Y. That is the sequence in which the output of train test split is. So train underscore test underscore split. Okay, clear? Now, what is the input for the train test split? I told you it is features, y variable, and ratio. Okay. Now, how do I pass only the features to my data set? Now, this data set contains all the columns. Then I'm passing the y variable separately, then the ratio. Okay. Now, in Pandas, there is a function called drop. So if I drop a column, what is the return value? Everything except the drop column. Okay. So here, if I drop from the data, the y value. So what is going to be the return value? All the features. Okay. So that is what I'm going to do. So the first parameter is data dot drop y comma 1. Y comma 1 means One is the axis. Okay. Because I can drop even the rows using the drop function. So y comma 1 means drop this column and the axis is 1. So the return value is going to be all the features. Second parameter is only the y variable. So I will do data of y. So data of y means only the column name, which is y variable. And the last parameter is what is the test size. And that is going to be the percentage. And return trainx, testx, trainY, test.
Data typing or column variable data index of square bracket, they can be presented all column name.
No, only one column name, y variable. I'll show you how this works. So now how do I call this function? So now I can split data. So the function is split data. What is the data? Concrete data. What is the y variable name? I have already created the y variable name, and that is called CCS. And should I give a value for the percentage? It is already defined as 30%, so I need not give. And what is going to be the return value of the function? Trainx, testx, trainy, testy. Okay, so I'll write trainx, testx, trainy, testy. Okay, so now you can find out what is the length of the train data and the test data. So I can write print trainx equals I want to find out how many records are there in the training data. So length of trainx so 721 records. Okay, so if you want to give instead of the length, you can give the shape. So this will give you the total number of 721 records and 8 columns, and Y will have only one record. Sorry, one column. Okay, same thing you can do it for the test. So in the test data, 309 records and 8 columns, and test Y 309 records. So the shapes are matching. The size is also matching. Now we are ready for the model building. Okay, your question, how do you read a correlation matrix? Now let's assume that I have 3 features, x1, x2, x3. I'll take one more, x4. Okay. So in the parameters, you would have seen X tick labels and Y tick labels. Okay. So this is the Y tick labels. Similarly, I have X tick labels, X1, X2, X3, and X4. So these labels are nothing but the names of columns. Okay. Now, what is the correlation of a column with itself? It is always 1. So the diagonal will always have the same value, 1, 1, 1, 1. Okay. Now, what is the correlation of x1 and x2? That is the same as x2 and x1. So these two are the same as these two. Correct? So if x1 and x2 is 0.2, this will also be 0.2. Okay, so there is a repetition of every value in this triangle. If you consider this to be a triangle, okay, this to be a triangle. Okay, so we have a lower triangle, upper triangle. So because the values are repeating, so I'm going to take only the lower triangle. Upper triangle will have the value 0. Okay, so if this is 0, 0, 0, 0. So I'm going to take only the lower triangle. So let's put in some dummy values. This is 0.2, x3 and x1, 0.95. This is minus 0.3. This is 0.04 minus 0.003. And this is 0.17. Okay, now how do you interpret the results? What is the relation of x1 and x2?
Positive.
So x1 is here, x2 is here. What is the intersecting point? 0.2, which is a positive relation. But is that highly positive?
No.
No, it is positive. What is the relation between x1 and x3? So x1 is here, x3 is here. So this is 0.95. So we can say this is highly positive. What is x1 and x4? So x1 is this one, x4 is this one, 0.04. So we can consider this to be 0 relation. So we can conclude x1 and x4 are independent features. Right? So x1 and x4 independent. What about x1 and x3?
Dependent.
They are dependent. So that means I can either have x1 or x3, not both. Okay, so if I remove x3 from my data set, this relation is also gone.
Okay.
What about x1 and x2? 0.2, so it is small. So I will retain x2 because x1 and x2 are independent. Now come to the next one. x1, x2 already taken care. x2 is 1, so ignore. x2 and x3. So x2 is this one, x3 is this one, minus 0.3.
Negative.
It is a negative correlation, but is that significant? Maybe not. So I'm going to retain x3 because x3 and x2 are independent. Then x2 and x4 minus 0.003, which is negligible. That means they are independent. So I'm going to retain x4. x4 is already here. x2 is already here. Okay. Now what else is remaining? x3 and x4, which is 0.17, which is a just positive correlation. So retain x3 and x4. So my final data set will have x1, x2, x3, x4. For the time being, I'll take this. Okay. And depending upon the model results, I can choose to drop x3 because of one relation with x1. So this is a iterative process. You start with all the features, then this is called backward propagation. There are two types of model building, forward propagation and backward propagation. In a forward propagation, you add one feature at a time. Start with x1, build the model, check the performance. Then add x2, build the model, check the performance. Whether x1 and x2 have a relation, then add x3, and that is how you go. In a backward propagation, you take all the features, build the model, and then work your way back. So you keep removing features before you finalize your final set. Okay, so choice is yours, how you want to implement. समझ में आ रहा है?
Yes.
Online, any questions from anyone?
So I was. So what is equal to only here? What is equal to CSS? Or somebody can add.
I am assigning a variable called y with the y column जो हमको predict करना है. ठीक है? क्योंकि बहुत सारे पे functions हम लिखेंगे जहां पे we'll be passing the y variable. So instead of hard coding CCS or CSS, so just pass the value y. So that you don't.
Global function के use.
Global function नहीं है. It is a, I won't call it as a global variable. Its scope is limited to that particular program. Don't define this as a global. अगर आपको local करना है तो every time you have to extract that column from the data set which is not worth. क्योंकि you don't even know what is a y variable. Na? So something you need to know something. So that's why I'm defining a y variable with the value CCS.
The output value.
It is not the, that is the output value. It is already assigned, isn't it? CCS is already there. So it y है, I think it is right at the top. So, यहाँ पे यहीं पे नहीं था वो. ये जो है ना, CCS is the name of the column. Y is the Python variable name. ठीक है? अभी मान लो मैंने 10 फंक्शन लिखे हैं. Every function का एक input is the column name. Okay, so how do I pass that column name? Either I can hard code it as CCS, or I can simply pass the y, क्योंकि y के अंदर क्या वैल्यू है, CCS है, ठीक है, इसीलिए this value has been defined like this. Clear? Okay, so now we'll go to the model building part. So model building will take two parameters, which is the training data. So train X, train Y. So model equals. So SM is the stats model, the library, what I have defined at the top. And in that, OLS, ordinary least square method, which will take two values. The first parameter is the train Y and then train X. Okay, it is always Y and X. Then fit. Now print the model summary. So print model dot summary. Now I can also do the prediction in the same function itself, but because there are some other steps before the prediction, so I'm going to stop it here. Okay, and then carry out the other steps. What are the other steps? Number one, check the assumptions, then cross validation, and then finally we have the model building results. Okay, so right now just return the model name. You're tired?
Not very good. Not very good.
So now you can build your model. So let's call this as model 1. The input is train X and train Y. Okay, so now let us run this. Summary within quotation mark. And now this is the summary of the model. So we have R square, adjusted R square at the top, right? This is adjusted R square. This is R square. Then F statistics of the model, then the AIC square. Okay, then these are the features. Coefficients kya hai? What are these coefficients? They are the beta values. Okay, B1, B2, B3, B4, B5, B6, B7, B8. There are 8 features. So these are the beta values. Okay. Then for every feature, we have the T statistic, which is this one. And what is the corresponding P value, which is this. Understood? अब इसका significance क्या है? What is the significance of this output? This will enable us to do feature selection. Is CComp, that is Seven composition, is this significant? Yes or no? Is slag significant? Yes or no? Is fly ash significant? Yes or no? Okay. So on what basis are we finding out the significance here? P value?
Greater than 0.05.
Significance is P value less than 0.05 or T value greater than 1.645. Okay, this or this. अभी कॉम्प का देखो 22.2. So where will it fit? Into the rejection region. So it is a significant feature. I think last class I told you, what is the hypothesis behind this? You know it is significant or not. But why it is significant, that is something I think वो शायद करवाया नहीं था. Okay. What is the formula for linear regression? We'll quickly cover this. Y hat equals A plus A is the slope, intercept, then B1 x1 plus B2 x2 plus. So in this case, we have 8 variables. So we have B8 x8. Okay. Now we say that x1 is significant based on that output. ठीक है, तो beta value कितना आया है? Sorry, not beta value. The T statistic कितना आया है? 22.2. Okay, and we say x1 is significant. Now, what is the theory behind this? Why is it significant? The hypothesis for that is the beta value for x1 is 0. And the alternate hypothesis is the beta value for the x1 is not equal to 0. Okay. It can be any x. I'm just putting x1 since we are talking about the feature x1. Okay. Now, for a moment, just assume B1 equals 0. So what will happen to the equation? If B1 is 0, so अगर B1 0 है, then x1 is not 0. The combination of x1 multiplied by b becomes 0. That means x1 has no significance. है कि नहीं? Because its corresponding weights are all zeros. तो ये इक्वेशन क्या होगा? This will become a plus b2x2 clear? So that is the reason we check, can b1 or can the beta values take 0 or not. If it can take a 0, that means the feature is insignificant. If it cannot take 0, that means the feature is significant. Now, is it clear now?
Yes.
So if you look at this output, we can see that every value of t, which is a t statistic, is significant. Agar minus hai to why is it significant? You have to take the modulus. Because minus 8.8 will be checked against minus 1.6, not plus 1.6. Because it is assumed to be a normal distribution, every minus will have a corresponding plus. So minus 8 will be minus 1.6. ठीक है, तो minus 8 कहाँ पे है? Which is less than minus 1.6. So minus 8 will be here, minus 1.6 will be here. उसको reverse करोगे, 1.6 is here, 8.8 will be here. Interpretation same है. Only thing is it is the mirror image.
Sir, the t statistic is less than 1.64 and p value is greater than 0.05. Will it happen?
Sorry, come again. If the
t value, the t statistics value is greater than 1.64.
Okay, let's put 3.
And p value is less than 0.05. Will it ever happen?
It will be.
So what do we do in there?
No, it is automatic.
P value is greater than 0.05.
That cannot happen.
Okay.
Just think. Okay, this is a normal distribution chart. This is 1.645. Okay, what is this area? How much is this? ये कितना है? This area is how much? 0.05. Okay. Now, if I have a t statistic greater than 1.645, so that means ये area ले लेते हैं. This is 3.1. So the area will always be to the right of it. तो ये area कितना है? Less than 0.05 है ना? So this is always less than 0.05. So simple logic, high t, less p. Okay. So according to this summary, all features are significant. Can you tell me why is it showing like this? Okay, before you answer that, should I consider the cutoff to be 1.645 or 1 or some other value? Sure. Online, anyone? Should the cutoff be 1.645? Okay, I'll give you the number. Or should it be 1.96? Suppose I tell you it should be 1.96. Why should we take 1.96?
Lowest speed that if I want to if the lowest peak stat value 1.9.
Lowest T is 1.96. Huh? So simple. It is a two-tailed test. What is the hypothesis testing? I told you H0 B equals 0. What is H1? B not equals 0. So what kind of a test is this? Two-tailed test. So two-tail pe kya karta hai? Alpha becomes alpha by 2. So 0.05 becomes 0.025, which is 1.96. Okay, now when you take 1.96 as the cutoff, now your whole interpretation will change. Just by that fraction of a number, now you can see that CAGGR is not significant. Okay, and look at the p-value. 0.04. Just slightly. So I can consider this feature to be insignificant. Okay, and even the other variables I'm seeing they are significant. That may not be true. The reason is we have not removed multicollinearity. Multicollinearity हमने देखा है. We saw the graph. We saw there were some multicollinear features. But have we removed them? Or have we converted them into variables? Have we combined them? कुछ नहीं किया है. They are still existing. So that is the reason why the summary sometimes can give you misleading information. Are you getting this point? Okay, so this is not a Bible that जो भी है यहाँ पे everything is fine. No? You have to interpret it in your own way, depending upon what is that you have done to the data. Okay. Are you able to plot the summary? Summary दिख रहा है? Okay. Online people, any questions from anyone? So after the model, now we have to validate the assumptions. So first assumption is that the mean of residuals is 0. So we have the M1, which is the model, and the residuals of this. These are the residuals. That is when I build the model and predict it on the same data. Okay, so that residual, it has to be approximately 0. So you can do np.mean. So here you can see that the number is minus 0.005, very small number. So you can consider that to be a 0 value. Okay, what are the other assumptions? Distribution. Okay, normal distribution of data. So this we have already done in the code above. Plot chart. Okay, you have to study the distribution to check whether they are normally distributed or not. Then the third is no outliers. We have already done this also using the box plot. Okay, so study the chart to identify outliers and fix. Then rows should be greater than columns. Okay, this is also we have done by doing the shape function 1030, I think, total number of rows. So rows is greater than columns. Now comes the big check. क्या है वो? Heteroscedasticity. So check for hetero or okay, so again, I'll be writing a function because I can build multiple models. Every model has to be checked for hetero or homoscedasticity. So we can write one function to check hetero skedasticity. So this is going to take two parameters. what is the model name and what is the train Y data, because this has to be checked for errors. Error versus train Y. So errors I will get it from the model. Train Y I'm passing it as a parameter. ठीक है? तो क्या टेस्ट है heteroscedasticity का? How do you check? I told you there are two ways in which we can test it. One is by plotting the graph, the errors, right? You will get a graph. So if it is parallel, it means it is constant variance. So we have to find what is the degree. Okay, so the graph will tell us to some extent what is the degree of heteroscedasticity in the data, in the model. Second method, कैसे find करोगे? Brosh-Pagan test. Remember last theory में किया था last week. I told you there are 5 to 6 tests available: non-constant variance test, Brosh-Pagan test, White's test. So we will do these two in the same function so that you can cross-validate whether the graph and the result of the test are they similar or dissimilar. First, plot the errors. Plot the model errors. So I'm going to use the Seaborn library and the PyLab, the residual plot.
Sir, can we get this homo and hetero from p values?
Yeah, we are going to do that now. So the residual plot will take three parameters. First is what is the x-axis, which is the errors. So M1 dot residuals. The y value is going to be the train data. That is the train y. Then the chart, if you remember, I told you, if I plot it like this, this is the 0 line. These are the positive errors. These are the negative errors. And this is the distribution of the errors. And this line, okay, this if I have to show, you want to display this or not display. So that parameter also has to be passed as a input to the function. So LOWESS. So Lewis is true. It won't show you that line. Locally weighted squared. That is the. And what color you want for these errors? So you can put any color here. Let's say blue, for example. Okay. So first let us plot this and see, and then we will write the Brosh-Pagan test. So the model is called M1. The train Y is train Y. Now tell me, is this having heteroscedasticity or homoscedasticity? Okay, if you can see the output, you have a 0 line. Positive errors, negative errors, and then you have this line. So to conclude that this is a homoscedastic model, you have to find the degree to which this line is bent. Okay, ideally you should have this, but here we are having this. So to some extent, I can say this is heteroscedastic. Okay, but if you feel that I am okay with this kind of a model, you can consider this to be as a homoscedastic also. Okay, it is all up to your interpretation. Is this clear?
Sir, I'm getting an error. Non-type object has no attribute beside. Non-type object has no attribute beside.
Non-type. The return model, so you have commented out. So that returning a null. Now run the compiler function.
Split the data.
Now run the function. So now we'll write a small function to check the heteroscedasticity using the Brosh-Pagan test. So the function name is het underscore Brosh-Pagan, which will take the same parameters, which is the model, residuals. Okay, so M1 dot residuals as the first parameter.
Sir, what if we don't check for the heteroscedasticity of the model?
Your model can overfit.
So it is kind of a question.
Underfitting will depend upon how many, it will depend on the cross-validation results.
So for that, we don't.
For underfitting, number of features.
But like if there are chances of overfitting a model,
Yes.
that is the reason we are doing this Sacred elasticity.
Correct.
Then what if our model will be underfitting? Is there any test something?
Or underfitting.
So,
Even for overfitting, there is no test as such. It is based on the cross-validation results.
So, can you please say that this Sacred elasticity cannot define whether the model is overfit or not? It is just.
We can, to some extent, we can say, depending on the shape of the curve.
So now we got the error string. It was used straight and it was again in negative axis as well. So then can we say, but it was a very small part of negative string. So can we say our model can overfit because of that small part?
No, we cannot look at that in isolation because your model also has multicollinearity. All these are linked. Why does heteroscedasticity happen? Because of multicollinearity. So if you fix multicollinearity, this thing is also fixed. Okay. If you do not fix it, multicollinearity will cause overfitting. And because of that, you will see in the summary, all features are significant. Because of that, you will see R square value is becoming 93%, which is considered to be a very good model, which is a wrong interpretation. Just because R square is high doesn't mean good model. So everything is interconnected. So if you fix one, everything will get sorted out. So these are, plugging the model at various levels. If I do not use this, okay, I can fix it here. If I do not do it here, I can use variance inflation factor, VIF. You must have done that. But VIF the problem ye hai ki it doesn't tell you which feature is correlated with what. It will only tell you which feature has to be removed because of the high value.
So now in this case, we have two outliers, right? If we see for that box plot, no? So we can see there are outliers.
There will be outliers, correct.
So if we fix the outlier, the R square value will also be changed, right?
No, R square has nothing to do with outliers. R square is mainly to do with the number of features. Outliers will fix distribution. Clear है? So Brosh-Pagan takes two parameters. What is the residual and what are the exogenous values, which is nothing but the input data. That is the features. So M1 dot exo. Okay, so this model.xor, which is called exogenous parameters, they are nothing but the input data in a matrix form. Okay. Now, if I run this function as it is, it is going to return me 4 values. Okay, this Brosh-Pagan test will return 4 values. Now, out of these 4 values, the second parameter is the p-value. That is what I have to check for significance. Models.stats.api has no attribute head Brosh-Pagan. Why? Just give me 1 minute. Spelling mistakes.
There is a C after S. C after S. Right there.
BREUS. Just spelling mistakes. Yes. Okay, now if you look at the output, you will see there are 4 values. We are interested in the second parameter, which is the p-value. So the return value is less than 0.05. The model is heteroscedastic. So null hypothesis, model is homoscedastic. Alternate hypothesis, model is heteroscedastic. And now you can check for the results. Model is heteroscedastic. And now check the results with the graph. Okay. Now, this does not mean that I should not go ahead with the predictions. This is only the degree of heteroscedasticity that is shown. But I know that there are some problems with the data because multicollinearity has not been fixed. Okay. Now, in such situations where you have a case of heteroscedasticity, there is a way to convert hetero to homoscedasticity. I told you there are two ways to do it. What are they? You transform the features, leave the Y as it is. Or you transform the Y, but leave the X as it is. Okay? So क्या मतलब है? If I transform the features, now if I look at train X, this is my original data. Now I do a transformation on this. For example, I do a log transformation. So all these will be log transformed. Okay. For example, if I do np.log train X. Okay, now you can see the difference. Original data, transform data. So I transform this data, leave the Y as it is. So what is the Y? Y is this. So my next model will be built on log transformed X with Y as it is. Check for heteroscedasticity on this. Okay, that same cycle will repeat. The other option is I transform the Y but leave the X as it is. That is called Box-Cox transformation. Are you getting this? So now we have identified there is a problem with the data. So there is heteroscedasticity. So we'll just leave it as it is. We'll do the prediction and then we will do the fine tuning of the model. So let us go ahead with the predictions. यहाँ तक हो गया सबका? The code. What errors? PRC is not valid. It's PRC. Is it very complicated?
Not complicated.
Functions for first time, so otherwise in notebook it was like we used to take the
notebooks. But notebook, they don't support the using of classes, and normally industry where we use the Python files. That is the VY extension. Python, that is only for learning purpose. You won't be able to see the list of variables defined, debugging the concept state. Here we can debug the code line by line, step into it, see the changes. Online people, any questions?
Sir, can you show us that variables of train X and train Y? Like
The variables.
Before the prediction, we can check variable values train X and train Y.
Yeah, 1 second. The splitting part, isn't it this one?
Yes.
You wanted to see the count or the data?
Count.
Okay, the count is the train data. Train X is 721 records and 8 columns. And for the test, it is 309 rows and 8 columns.
Yes, okay. Yes, sir. Got it.
So now we can do the prediction and calculate the errors. So predict function will take, so we can call this as predict Y. So predict function will take the model. The test X data and the test Y data. Okay, so now you can do the predictions. And if you want, you can round this off to 2 digits after the decimal, and then store actual and predicted data. Okay, so this is the prediction. The actual data is test Y, predicted data is the pred, storing the results in a data frame. And then I'm going to add one more column, which is called residuals or the error in prediction. So I can write error equals df dot actual minus df dot predicted. Then calculate the mean square error. So MSE equals, so I have already written this, load the risk library called mean square error. So mean square error, this will take two parameters. What is the actual data? Actual data is test Y. Predicted data is right. And then return the data frame and the mean square error. Okay. So the data frame is actually the results. So results 1, MSE 1 equals predict Y using the first model M1, test X and test Y. Okay, and print model 1 MSE equals format MSE. So it is 101.96. Okay, now we can check what is the actual data and what is the predicted data. So actual data 45.8, predicted value 36.8. For the first test record, the error is 9. For the second one, 33, expected value, predicted value 52, the error is 0. Actual and predicted, A minus B.
So you have done this for testing, that is with 0.3. So why is 70%? For training, you are covering all the steps.
No, training, why should you do this? What you are asking is cross-validation process. Cross-validation we have to do.
I mean, that's what. For now, we are just predicting it, and then we have to
The cross-validation will come before the predictions. Cross-validation, it is, you have to first split the training data into K parts. Because I cannot do the same procedure.
So earlier what we did was we did the same procedure for both, and then we checked the difference between ours.
That is not how the cross-validation works. Cross-validation, you have to first split the data into K parts. So let's assume that your trained data has 500 records. Okay. And the test has 100. Okay. So first you build the model here. And then you do the cross-validation. So this 500 is going to split into K parts.
So let's say 100 into 5. 100 into 5
Depends on the value of K. Okay. So for example, if K equals 5. Okay. So you will have part 1, part 2, part 3, part 4, part 5. Part 1 is nothing but the data. Okay. So part 1 will have 100, 100, 100, 100 and 100. Okay, so we'll have 5 data points split equally. Okay, so each portion will have 100 records of the training data. Out of which 4 parts will be treated as trained data, and 1 part will be treated as and each part will take part in training and testing. Okay. So there will be 5 iterations because there are 5 values for k. So when k is 1, I will have train data, I will have test data, then I will have this. So first iteration when k is 1, what is going to be my train data? It is going to be 1, 2, 3, 4. Test will be 5. 1, 2, 3, 4. Test will be 5. Then I'll have some errors. Let's call this E1. Then in the second iteration, test will come to the train. So this will be 5. 1, 2, 3. This will be 4. Then I have errors too. Error means that model will be built on the train, prediction will be done on the test. Okay. So same thing for 3, 4, 5. So every data takes part in training and testing. 5, 4, 3, 2, 1. Then I have E1, E2, E3, E4, E5. Then end of the iteration, I'll get a sigma of error. Okay, which I have to calculate. Sorry, not calculate, I have to take the mean of this. So what is the mean cross validation error? It's going to be sigma E by A. So this number should match the MSE of test. Okay, not exact, but it should be very close to the cross validation. So if they are similar in nature, it means the model is good. If the testing error is less, then also it is good. But if the testing error is more, proportionally, it is more than the training error, it means overfitting. If the training error is proportionately more than the testing, then it means underfitting. Okay, so what is left is the cross validation part, data transformation procedure, and the box transformation. That we'll do it in the next class. Questions from anyone? Online people, any questions? Nothing. So, okay, so we'll stop here today.
Next year sales.
2000 and
So that will be one column, the month name. Second will be the let's say sales. Sales it can be in amount or it can be in pieces sold. And the third one will be to predict it for next year.
Yes.
So how do you approach?
Use time series modeling for this. 1 minute. Online people, any questions from you? I'll share this file. I'll send it on the WhatsApp chat on that group. Okay, I'll put it there. You can get it from that. Okay. So thank you, everyone. See you tomorrow. I guess it's a holiday. So next Saturday we will meet. All right. And in case if you have anything during the week, put this on the chat and I'll reply to you. Okay. Thank you, everyone. Have a good weekend. And see you next week. Bye-bye.